7.6, factoring ax squared plus bx plus c. So we're going to be factoring trinomials in this format where a, b, and c are numbers. So like this, right? And that's in that format, so is this one, okay? So whenever you're factoring polynomials or doing any factoring at all, you want to factor out common factors first. So I'm looking at all three terms. I'm thinking, does anything go into all three of these terms? And since the numbers are all even, that means 2 goes into everything. So I'm going to factor out a 2. Okay? So then I'm thinking about distributing. 2 times something is 2x squared. That would be x squared. 2 times something is 10x. That would be 5x. And 2 times something is 12. That would be 6. Okay? So now I've factored out the 2. Now, often I'll see students just write this and say, oh, I just divided everything by 2. And the 2 just disappears. But you don't want to do that because this is an expression that we're factoring. So the 2 is still you can't just take this trinomial and change it into that one and say they're equal because one's twice as big as the other. If you had an equation where you're dividing both sides of the equation by 2, you could do that. But here you can factor out the 2, but it shouldn't just disappear. This is still going to be part of your answer. Okay? And then I've got this trinomial in here, which I can factor further. Since this one now begins with an x squared, the trinomial, there are a number of different methods you can use to factor it. I'm going to use a diamond problem, which I explained in the last section in 7.5. But what you do is you make a little x, okay, and then you take the b value. The b is the coefficient of the x, and I'm using this b value. So I want, this is, you're using the trinomial that begins with x squared, not the original that begins with 2x squared. So my b here is going to be 5, and then the c is going to go on bottom. That's the 6. Now this is a little puzzle. I'm looking for two numbers that add to 5, and the same two numbers should multiply to 6. So I usually like to start with the bottom, thinking about ways to multiply to get 6. I only want to use integers. I don't want to use any fractions or decimals. So there's really not that many ways. 1 times 6 is 6, but that adds up to 7, not 5. Negative 1 times negative 6 is also multiplies to 6, but it doesn't add up to 5. So let's try this with, those are our only 4 options, and only one of those 4 adds up to positive 5. That's the 2 and the 3. And the 2 and the 3, and you could write it in as 3 and 2 if you wanted. It doesn't matter what order. But that's what goes in the back of these parentheses. So I've got a 2 here and a 3 there, or reverse them, that's fine. And then I separate them from the x's with a plus sign. And now this is completely factored. And you could always test your answer by multiplying it all back together. It should get you back to the original trinomial. Okay? All right, next problem. All right, so I'm looking at these 3. 3 goes into all of those, so I'm going to factor out a 3. 3 times something is 3x squared. That's x squared. 3 times something is 18x. That's 6x. And 3 times something is negative 21. That would be negative 70. Negative 7. And then I'm going to factor the remaining trinomial. I'm going to use a diamond problem. Got another method that works. That's fine. So I'm going to put the 6 up here and the negative 7 there. So now I'm looking for two numbers that multiply to negative 7. Well, there's not that many options. There's really only 2 options using integers, and the only one that adds up to positive 6 is that one. So I got negative 1 and positive 7. And again, you can reverse the order of the factors. That's fine, but the 1 has to be negative and the 7 has to be positive. And so this is completely factored. Okay. So if you can factor out the number in front of the x squared, then the problem's not really much more difficult than a problem that begins with x squared. It's just one extra step. Sadly, you can't always factor it out. Okay, so if you look at these 2 examples at the bottom of the page, 2 doesn't go into 7 or 3, and then 3 doesn't go into 13 or 10. So I can't factor out the 2 and the 3. So I need another method, and I'm going to use a method that I call the modified diamond problem. So I'm still going to use a diamond problem, but there are going to be some more steps. Okay, and I've got directions written out here, but it's going to be easier for me just to show you with this example. So first thing I try to do is try to factor out the 2. That's a dead end, okay? So then when you can't factor this number out, I'm going to take this number and I'm going to multiply it by the c. And the c here is 3. So I'm going to take the 2 and multiply it by the 3. I'm going to create a new trinomial. So this is just a little arrow here. So my new trinomial will begin with x squared because I'm going to be moving that 2. 2 times 3 is 6. So now it's going to end with 6. So now I've got this nice trinomial here that begins with x squared. And I'm going to use a diamond problem on that. So I'm putting a 7 up there and a 6 down there. Okay, and then I'm thinking how to multiply to get 6. I could use a 1 and 6. I could use a 2 and a 3. Or I could use the double negatives. But there's only going to be one winning combo, and that's 1 and 6 here. 1 times 6 is 6. 1 plus 6 is 7. Okay? So when I factor this trinomial, I'm going to get x plus 1 and x plus 6. Now here's the danger of a modified diamond problem. A lot of people are just going to put that as their answer. But if you multiply this back together, if you FOIL it together, you're going to get this trinomial, not this one. Okay? So we're not there. So in the beginning, we changed the problem. We changed the original trinomial. We modified it. Okay? So now we're going to undo what we did at the beginning. So since we multiplied by 2 up at the top, now I'm going to take the number parts, not the x's, but the 1 and the 6, and divide those by 2. So that's the opposite of multiplying by 2. Okay? And I'm going to write this as a fraction. 1 divided by 2, you could write that as 1 over 2, right? And this would be 6 over 2. Okay? So then I want to simplify these as much as I can. I can't do much with 1/2, but 6 divided by 2 is 3. So I can write this part as x plus 3. Okay? Now when you have a fraction that you can't reduce, like with the 1/2, what I'm going to do is take the denominator, the 2, take the bottom of the fraction, and I'm going to pull it out in front of the x. So this is going to be 2x, okay? And then the 1, I pulled the 2 out from under the 1, so the 1 just falls to the ground, and that just becomes a 1 there, and then we have our solution. Almost like magic, okay? So you can always test out your answer by foiling it back together, should equal this, okay? All right, let's try another one. So I can't factor out the 3. So that means I'm going to do this to create a new trinomial. 3 times negative 10 would be negative 30. Okay, now I'll set up a diamond problem. Don't forget to bring the negatives with those numbers. So I'm looking for two numbers that add to negative 13 and multiply to negative 30. So since I'm multiplying to get a negative, I'm going to need a negative and a positive. So I'm just kind of brainstorming some different ways. Well, neither of those is going to add to negative 13, so let's keep looking. Okay. And hey, I found one. So yeah, it's true, you could use a 5 and a 6 if one of them's negative. But I already found a winning combo, so I'm going to stop there. So 2 and negative 15 works. So this will factor into x plus 2 times x minus 15. But then you have to remember to undo what we did at the beginning. So in the beginning we multiplied by 3 since this a value was 3. So now I'm going to divide just the number parts by 3. So creating some fractions here. Okay, and I'll reduce those as much as I can. I can't reduce 2/3. So that means I'm going to pull the 3 in front of the x. The 2 will fall to the ground, like so. 15 divided by 3 is 5, so this is going to be x minus 5. And there's my solution. Let's try some more on the next page. So, next example. 6x squared plus x minus 1. So, there's no common factor here. Nothing goes into all three terms. And I've got that number in front of the x squared, so I'm going to use a modified diamond problem. I'm going to take the 6 and multiply it by the negative 1 to create a new trinomial. So this will be x squared plus x, and then 6 times negative 1 is negative 6. Okay, and then I'm going to set up a diamond problem for this trinomial. So when we're looking for the number on top, there's no coefficient in front of the x. There's no number there, but you could think of that as 1x, right? So this would be a 1. And then on bottom I have negative 6. So looking for two numbers that add to 1 and multiply to negative 6. Okay, so I'm going to start brainstorming different ways to multiply to get negative 6. Okay, I got that and this. Well, neither one of those add up to 1. So let's try it with a 2 and a 3. One of them would have to be negative, one would have to be positive. And there's only one pair there that adds up to positive 1, and that is that one. So that means that this trinomial will factor to x minus 2 times x plus 3. Okay, but that's not my final answer because I changed the trinomial at the beginning. I modified this. I modified the problem. Now I got to modify the answer. So in the beginning I multiplied by 6. I got to do the opposite of that now. I'm going to divide by 6. I'm going to divide just the number parts by 6. So there I'm dividing by 6 and writing that as a fraction. Okay. Now at this point I see a mistake sometimes where people will pull the 6's out in front of the x's and say 6x minus 2 times 6x plus 3. But you don't want to do that because these fractions aren't reduced. That will give you the wrong solution. So you need to reduce fractions first. So that first fraction you can divide top and bottom by 2. That would give you 1/3. Second one, 3/6 is going to reduce to 1/2. Okay. So now that I've reduced and I still have fractions, now is when I pull the denominator out in front of the x's. So that will give me 3x minus 1 and 2x plus 1. Okay, and that is my solution. And as always, you can check this by foiling it together. That should put you back to 6x squared plus x minus 1. Okay. All right, next one. There's no common factor here either, so I'm again going to modify by multiplying by 6 here. Okay, so that will give me x squared minus 7x plus 12. Okay, let's set up a diamond problem for this. Got a negative 7 there and a 12 there. So I'm looking for two numbers that add to negative 7. Same two numbers multiply to 12. Okay, so let's start thinking about that. Well, anytime you're going to use two positive numbers, it's going to add up to something positive. So I'm only going to check double negatives. Okay, so those would multiply to positive 12, but unfortunately they don't add to negative 7. So let's try another combo. Let's try a 2 and a 6. That would multiply to 12, but it adds up to negative 8. Okay, so let's try a 3 and a 4. Hey, that multiplies to 12 and adds to negative 7. So that is my winning combo here. So x minus 3 times x minus 4. Okay. And then I have to undo what I did at the beginning. I multiplied by 6 at the beginning, so now I'm going to divide the numbers by 6. And again, you want to reduce before you pull the denominators out in front of the x's. So this will be 1/2, and then those are both even numbers, so you can divide by 2 on top and bottom. That gives you 2/3 there. Okay. So now that I can't reduce these fractions anymore, that's when I'm pulling those numbers out in front of the x's. So the 1 will just fall to the ground there. I'll have 3x, and the 2 falls to the ground here. And there's my solution. Okay. All right, let's try a couple more. So next one. So it's tempting on a problem like this. This is another common mistake I see a lot, is that people will look at this and they'll just start modifying it. They'll take the 4 and multiply by the negative 2. And that won't quite give you the right answer. And the reason why is because there is a common factor. So you always want to be on the lookout for that and factor out common factors first. So all three of these terms are even. So that means we can factor out a 2. And I'm thinking 2 times something is 4x squared. 2 times something is 2x, that would be x, and 2 times something is negative 2, that would be negative 1. Okay, so I got it down to this, and don't throw away the 2. Some people just say, oh, I just divided everything by 2. Well, you factored out a 2, but 2 is going to be one of the factors when this is finished. Okay, so it looks like we'll be able to factor this more. So now what I'm going to do with this trinomial, I've still got the 2 to deal with. So now I'm going to do a modified diamond problem with this trinomial, okay? So that's going to give me x squared plus x minus 2 once I modify it, okay? And then I've got a 1 in front of the x there and a negative 2 down here, okay? Not too many ways to multiply to get negative 2. Those are my only 2 combos, and this is the winning one. Okay. By the way, if you ever do one of these diamond problems and there just isn't a pair that works, it just means that the trinomial is not factorable. So that is possible. Okay, so this factors into x minus 1 times x plus 2. Okay, but then I got to modify back. So up at the top, I multiplied by 2. Now I'm going to divide the number parts by 2. Okay, and I'll reduce as much as I can. This first one I can't reduce, so I'm going to pull the 2 out in front of the x. So that's 2x minus 1. And then this is x plus 1. Okay, now remember that we factored out a 2 at the very beginning. So I still need a 2 out here because, you know, this trinomial is the same as those 2 bits, but it still has the 2 out there as a factor as well. Okay, all right. And there's our solution. All right, let's try the next one. So looking at these 3 terms, this also has a common factor. So if you go straight to a modified diamond problem, it's not going to work out quite. So these are all even numbers. That means 2 goes into everything. And let's see, 2 times something is 6x squared. 2 times something is 14x. 2 times something is 4. Okay. Can't do, that's the only common factor it has, but I can still do a modified diamond problem to factor the trinomial now. Okay, so I'm going to multiply by 3 here. So 3 times 2 is 6. Okay, let's factor this part. 7 on top, 6 on bottom. Okay, so I'm only going to use the double positive versions here. So there's only 2 ways to multiply to get 6, multiply with integers with positive numbers to get 6, and that's my combo, right? So 1 and 6. Okay, and don't forget to modify back. So, you know, in the beginning we multiplied by 3, now divide the number parts by 3. Okay, now we'll reduce as much as we can. 1/3 you can't reduce, so pull the 3 out in front of the x. And then 6 over 3 is 2. 6 divided by 3 is 2. And don't forget, we factored out a 2 way at the beginning. So that's part of my answer as well. Okay, so all this work I was doing here was just for the trinomial part, but I still have the 2 as a factor. Okay? All right, that's the end of the section, and I'll see you next time.